Hello, everybody. How are you doing? It's me, Mourad Sultan Ezouidi, the pioneers in methods. Today, we will solve polynomial equation raised to the power 10. Okay, I'll just clarify the title first. I will write the title again. Okay, so we thought that today we are going to. I'll go first to this one. Okay, YouTube. Okay, channel. Okay. 1 minute. I will come make it. Okay. Okay. So, sorry. Okay. I'll share this first. Oops. Okay. So today we told that we'll solve using the discriminant formula of Mr. Mourad Sultan Ezouidi. I will solve polynomial to the power 10. Okay. I'll just okay. This is yes. Now I'm going to share the screen with you, my kids, and prepare yourself for trying solving this 10th polynomial equation using the theorem of Mr. Mourad Sultan Ezouidi or the discriminant formula. Okay, so this is 10th degree polynomial equation. 10th degree polynomial equation is that. Now, my kids, here is the example. So I will now start from the beginning, and then we are going to conclude that we have, let's say, 10th uh, complex roots. Okay, means this 10th degree polynomial equation has 10 roots which are complex. Okay, not real. Okay, so example 5, I think. I have example 4. Let's check and do it. Okay, this is suppose that's done. So this is our polynomial to the power 10 learners is 10 raised to the power 10 minus 10 times x raised to the power 9 plus 45x raised to the power 8 minus 120x raised to the power 7 plus 210x raised to the power 6 minus 251x raised to the power 5 plus 205x raised to the power 4 minus 110x raised to the power 3 plus 35x squared minus 5x plus 1. Okay, this is the polynomial to the power 10. Okay, so try to join your lecture, professors and colleagues and students, to get to apply the discriminant formula of me, so that you will find the exact roots of this 10th degree polynomial equation. Okay, so our 10th degree polynomial equation has to be written in its standard form, which is x raised to the power 10 minus L0 of O the Q x raised to the power 9 plus L1 of O the Q x raised to the power 8 minus L2 of O the Q x raised to the power 7 plus L3 of O the Q x raised to the power 6 minus L4 of O the Q x raised to the power 5 plus L5 of 42 x raised to the power 4 minus L6 of 42 x cubed plus L7 of 42 x squared minus L8 of 42 x raised to the power 1 plus L9 of 42 equals 0. Now you can see this is in fact is coming to the power 10 simply because the highest power cannot be 10. Okay, and you can see here remainder theorem or factor theorem or uh, rational theorem or even method of Newton can be applied in this kind of question. Okay, because it will lead you to all the answers. So here, my kids, You are going to use the coefficient of this 10th degree polynomial equation, which are written respectively as 10, 45, 120, 210, 251, 205, 110, 35, and 5, and 1. So the last coefficient is 1. And the first coefficient here is 1. Okay. So now, my kids, you are going to use the, let's say, discriminant formula of Mourad, Sultan, and Ezouidi, and you will try to find the value of s minus 1. By convention, s minus 1, okay, if you replace k with 0, you will get this one equal combination and to 0, which is 1. So therefore, we admit, or we confess, or we demonstrated that s minus 1 is equal to 0. Okay, so the first coefficient of my Newton vehicle equation. Okay, now, my kids, for k equal 1, we will find S0. S0 is the sum of the absolutes of these 10th degree from the equation. Therefore, the answer is going to be unknown. It's 0. We apply here. We make our substitution. And, okay. And we found that S0, in fact, is going to be equal to 0. Okay, because minus 100 plus 100 equals 0 exactly, because minus combination 10 choose 1 times 10 plus 10 times 10 is 0. Always, for any nth degree polynomial equation, S0 is equal to 0. Why? Simply because the sum of the extremes of this new and degree polynomial equation, where n is going to be equal to 10, so it is equal to 0. Now, my kids, we are going to focus on the S1. To find S1, go back to the formula of Mr. Marsupial labeled or named a discriminant formula of Marsupial which is equal S subscript k minus 1 for the R, the sum from 0 to k, combination n minus R, choose k minus R, and raised to the power R different is equal to 0 of order q k raised to the power k minus R times R minus 1. We will replace k with 2 and we will obtain the last formula negative combination n choose 2 times L0 of ODQ squared plus L squared times L1 of ODQ. Okay, so now we calculate this S1 is equal to negative combination 1 choose 1 times combination 10 choose 2 times 10 squared plus 10 squared times 5 is equal to 0. Okay, now we continue. I will let the calculation for you make this because I already calculate this. So I will give you time to think of this question and do it as soon as possible, okay, as quick as you can. Okay, for us two learners, I will focus on meaning that after making k equals 0 in the discrete formula of Mourad Ezouidi as subscript k minus 1 for the r, so I will obtain combination 2 choose 1 times combination n choose 3 times a 0 plus 2 raised to the power 3 minus combination n minus 2 choose 1 n squared times a 0 plus 2 raised to the power 1 times a 1 plus n to the answer. Now I will give you time to calculate S2. I make this substitution, okay, the product substitution, and effectively this one S2 is equal to 0. We continue to find S3, just put k equal 4 in the discrete formula of Mourad, Sultan, and Ezouidi, and then make your own extension and make your own calculation and simplify where possible and write S3 in its lowest term, okay, or in its simplest form. So this one S3 is applicable for any individual equation, even S2, even S1, even S minus 1. Okay, so even S subscript k minus 1 for the R. Okay, so now my kids will just replace S3, which is equal to negative 3 choose 1 times combination n choose 4, and n is 10 times n0 for the q raised to the power 4 plus combination n minus 2 choose 2, n squared times n0 for the q squared times n minus combination n minus 3 choose 1, n cubed times n0 for the 2 times n2 for the 2 plus n raised to the power 4 times n for the 2. After, let's say, finding all the coefficients of this new 10 equation, you will figure out the 10 complex roots. and you see that this type of differential equation, in fact, has 10 complex roots. Okay, we figure this after making our calculation. Okay, so this is the value of S3 is equal to 0. I will proceed my kids. I'm going to find S4. To find S4 for K equal 5 and this will formula of most of our Sultan Ezouidi, then you are going uh, to rewrite this one after making the expansion and simplify where possible. So it has been written as S4 of order R equal 4 choose 1 times n choose 5 times n0 42 raised to the power 5 minus n minus 2 choose 3 and squared n0 42 cubed times n1 plus combination of course n minus 3 choose 2 and cubed times n0 42 squared times n2. Okay. Plus minus combination minus 4 choose 1 and then to the power 4 and 0 for 2 to the power 1 times and 0 for 2 plus and then to the power 5 times the 4. So here you are doing substitution with substitution. You will substitute, let's say, L0 with 10, L1 with 45, L2 with 120, L3 with 210, and L4 with 251. Okay? Then you will obtain that in fact this one is equal to negative 10 raised to the power 5. Okay, is equal to 10 raised to the power negative 10 raised to the power 5. Okay, simply because you can see 10 raised to the power 4 times 10 raised to the power 1 is a common factor, okay, of all the terms. So the sum of this is minus 1 multiplied by 10 raised to the power 5 is minus 10 raised to the power 5, means minus 100. Now for k equals 6, I will try to substitute k equals 6 in the discriminant formula of Mr. Multiplying Ezouidi. Therefore, we'll obtain the last formula that is simplified in its simplest form, negative composition 5 choose 1 times 9 choose a 6 times n0 42 6 plus combination 8 choose 4 and square n0 42 for 4 times n1 minus combination 7 choose 3 times n cubed times n0 q raised to the power 3 times n2 plus combination 6 choose 2 and raised to the power 4 times n0 42 raised to the power 2 times n3 42 minus combination 5 choose 1 times n raised to the power 5 times n0 42 raised to the power 1 times n4 42 plus n raised to the power 6 times n5 42. Now we make our substitution. We'll substitute, let's say, in this formula, the coefficient of my original 10th degree equation, okay, means from L0 up to L5, I will use all this coefficient and then I stop here. This is S5. S5 needs only 5 coefficient. Okay. Now my kids, it's clear this one after calculating, so you can calculate this is equal to 0. Okay. Now I will proceed. So we obtain now only two coefficients which are different to 0, okay, and the rest are 0 after up to this calculation. Now we continue to find the S6, put k equals 7 in this formula of me. We will elaborate to S subscript 6 for the equal combination 6 choose 1 times combination 10 choose 7 times L0 for the q raised to the power 7 minus combination 8 choose not 5 times n squared times L0 for the q raised to the power 5 times L1 plus combination 7 choose 4 n raised to the power 3 times L0 for q raised to the power 4 times L2 for 2 minus combination 6 with 3 n raised to the power 4 times L0 for q raised to the power 3 times L2 for 2 plus combination 5 choose 2 n raised to the power 5 times L0 for q raised to the power 1 times L4 for 2 minus my kids uh, minus minus we told. Okay, combination for choose 1 n raised to the power 6 times L 42 times L4 42 plus n raised to the power 7 times L6 42. Now we will use this general formula that has been derived from the theorem of Mr. Ezouidi when k equals 7. Okay, so you will use L0 and L1, L2, and L3, and L4, and L5, and you should start at L6 because L6, let's say the last term is L6. So we'll start at 110. We make our substitution learners, and the calculation of this, okay, is going to be equal to 0. S6 is equal to 0. Let's go to S8, and also here S8 matrix is going to be equal to 0. S7, sorry. To find S7, you should put K equal 8 in the decimal formula of me, or in my third theorem. Okay, so I will just make our substitution. This is the expansion of S7 of order R equal in its simplest form of K for this. So now we will use the coefficient. I will just use it from L0 up to L7. Means I will stop at 35. Starting from 10 up to 35. Now this calculation makes S7 here is equal to 0. Okay, it remains now S8 and S9. S8 here is going to be equal to 0, and S9 is going to be equal to 9. And S, we told S4 is going to equal to negative 1. So here, my kids, put K equal 9 as this formula of me, and we will figure out S8 equal combination 8 choose 1 times combination n choose 9 times f0 whole to the power 9 minus combination n minus 6 choose 7 n squared f0 whole to raised to the power 7 times f1 equal to the last combination n minus 2 choose 6 n cubed times f0 whole to raised to the power 6 times f2 whole to minus combination n minus 4 choose 5 n raised to the power 4 times f0 whole to raised to the power 5 times f3 equal to plus combination n minus 5 choose 4 n raised to the power 5 times L0 42 raised to the power 4 times L4 42 minus combination L minus 6 is 3 times n raised to the power 6 times L0 42 raised to the power 3 times L5 42 plus combination L minus 7 should be times n raised to the power 7 times L0 42 squared times L6 42 minus combination N minus 8 n is 10 minus combination 2 should 1 times n raised to the power 8, 10 is 10, minus 10 raised to the power 8, times L0 42 times L6 42 plus n raised to the power 9, 10 is, n is 9, so n is 10, so 10 raised to the power 9 times n 8. Okay, we will use your calculation and we make substitution. Okay, this value is going to be equal to 3. Okay, now for k equal 10, means I'm going to change in my discriminant formula. K equal 10, I will obtain S10 minus 1, which is S9. Okay, equals the sum from 0 to 10. Combination 10 minus R choose 10 minus R is 94. I take n raised to the power R, 10 raised to the power R minus 0 42 raised to the power 10 minus R times n minus 1 42. Now we make our substitution, and then I will get the general formula in terms of the combination. Okay, k minus r, n minus r, and let's say r minus 1 equal to 2. So this one has been written in its simplest form. Now I'm going to calculate this. Okay, so you can see this one. 10 choose 10 is 8 minus 10 minus 2 is 8. Choose 8 is 1. Okay, so this coefficient will be what? Except the first one to be negative. So I will use our calculation. So we got this one equal to 10 raised to the 4. Okay. Now I will make summarize. So in other words, S0 equal S1 equal S2 equal S3, which is equal to 0. Then S4 is equal to negative 10 raised to the power 5. Okay. And S5 equal S6 equal S7 equal S8 equal 0. Therefore, S9 is equal to 10 raised to the power 10. Means here, if I'm going to write my 10th new Newton equation, that is relative to the original 10th Newton equation, has to be written as that. x raised to the power 10 minus s0 for the x9 plus s1 for the x8 minus s2 for the x raised to the power 7 plus s3 for the x raised to the power 6 minus s4 for the this is different to 0 x raised to the power 5 plus s5 for the x raised to the power 4 minus s6 for the x cubed plus s7 for the x squared minus s8 for the x plus s9 for the equals 0. Therefore, you can see all these coefficients except S4 and S9 are different to 0. Means I will just make substitution. It will be x raised to the power 10 minus S4 for the R because it's different to 0 plus S9 for the R equals 0. Now we will use the discrete formula of Mr. Mourad from Ezouidi. Okay, we calculate. I will suppose now that y equal x raised to the power 5 squared minus s4 for the y, okay, plus x9 means I will obtain a second degree equation. I will apply again the discrete formula of Mr. Mourad Sultan Ezouidi. Okay, we have s0 is equal to 0, s1 is equal to s1 for the q dash is equal to minus s4 for the r squared plus 4 times s9 for the r equal negative 10 raised to the power 5 squared plus 4 times 10 raised to the power 10. This one is equal to, in fact, 2, 3, 4 minus 1 is 3, 10 raised to the power 10. Therefore, my kids, I will explain something to you here. Okay, you see, this is p of x equal x squared minus s0 for the q dash times x plus s1 for the q. You see, s0 is 0. Therefore, as x squared equal minus s1 for the q dash. That's why here I should write minus s1 for the q dash. Meaning this one minus s1 for the q dash is equal to, okay, equal to, let's say, s4 for the r squared plus 4 times s9 for the r. Okay, that comes from this. Why you put negative sign? Because when you want to solve for x squared, so plus s1 for the q dash will be transferred on the right hand side. When it is transferred, it transports with that a negative sign. Okay, if it is negative, it's negative to the positive answer. Okay, but in this kind of examples, the second coefficient has to be always positive sign. Okay, so when you change it, it will be. Okay, now we will apply. Therefore, y or x whatsoever. Okay, because there is y squared. Okay, so y is equal s4 because this is negative s4, negative is positive, plus root of negative s1 positive that divided by 2. So it will be negative 10 raised to the power plus negative 3 times 10 raised to the power 10. You see root of 10 raised to the power 10, I will write as 10 raised to the power 5 times negative 3. Of course, raised to the power half. All divided by 2. You see, this one, my kids, I will write it as 5 times minus 5 times 10 raised to the power 2. Because 10 raised to the power 5 is 10 multiplied by 10 raised to the power 4. 10 divided by 2 will give you 2. Okay? Then, of course, here is the explanation 2ki5 in general. Because 2ki5 in fact is 1. Is minus 1 raised to the power 2 times 10. The n is even so it will be amazing. Okay, now we will use this fact. I will take one positive and then the other should be negative. So therefore, this is the coefficient. This is, sorry, this is 1. Yes, this is 1. So it will be 5, 5 times 5 times what? Times 10 raised to the power 4. Okay. Times minus 1 plus negative root of 3i times explanation 2i times 5. Now this is x raised to the power 5 equals this. Therefore, essence subscript k from 0 to 4 is 10. Okay, is 10. Is okay. Let's see. Negative. So I will use this. Mhm. Alright, that's right. Hold on, minute. Okay. So this one, my kids, has to be equal to 5 times 10 raised to the power 4 times minus 1 plus negative I times explanation 2I squared I. Okay. Therefore, of course, this one I will make here divided by 2. Mhm, mhm, mhm. Okay, I prefer to write it. Okay, I will divide this by 2 as division divided by 2. I will write like that. Okay, so this one I will make 10 raised to the power 5. I will cancel this. Okay, so this is xk raised to the power 5 equal 10 raised to the power 5 times minus 1 plus negative root of 2I exponential 2k I pi divided by 2. Therefore, okay, so xk from 0 to 4 is equal to 10 raised to the power half. Okay, this one I will make divided by 2. Okay, divided by 2. Make it write it like that. That make 1 divided by 2. Then go back to change this one. Okay, it's like that. So of course here I will do the same. I'll put it here. Okay. Now this is the exits before the okay, the fifth first exits are my new calculator equation. That is written as x raised to the power 10 minus minus s squared over r times x raised to the power 5 plus s minus over r. Okay? Then the next it will be like that matrix. Okay, I'll change this by that. Then I will make here, okay, this one can be positive, yes, and the first positive, okay, exponential to k plus 1. Why? Simply because, you see, minus 1 minus root of 3I divided by 2. Minus 1, I will write it as exponential I prime. Then raise it to the power 5. So it will be exponential I pi divided by 5 times exponential 2k times I pi over 5. So it will be my case, I'll take 2k plus 1 over 5 times I pi. Okay, this is the roots. Now I'll change this one, of course, as that. Now I will use the first one. This is, I need this one, I mean. Okay, copy. I will put it here. Okay. And then, of course, it will be like that. This is the first fifth roots of my original and the original 10 degree from the equation, which is equal to 1 simply because the formula is 0 for the q plus s subscript k. Okay, it will be 10 because the first L0 is 10 plus 10. Why 10 here? Because simply because 10 raised to the power 5 raised to the power 1 over 5 is 10. Okay, so I will write this here. So now I will just go to the next one. It will be like that. A plus. I will make this. So this, my kids, the 10th complex roots of my original 10 degree equation. Okay, this is your pioneers Eastern Sultan Ezouidi. After 5 minutes, I will continue to solve this equation. You see this same coefficient, but here coefficient minus 1. In the previous example is plus 1. Now I change to minus 1. I will get real numbers. Okay, but this one has to be equal to 5. And I there is no I. Okay, so we will appear this in the second example after 5 minutes. Now it comes here. Then these are the solution, my kids. Okay, now I will go to GeoGebra to let him solve. And you will see how GeoGebra or AI or Windows Mathways solver can do this kind of thing. Okay, let's see. Else, Mr. Martin really the pioneers, the Tunisian researcher in the field of mathematics. Okay, Mathways. I went Windows, Microsoft, the team of Microsoft. Okay, is enabled to do this kind of example. Okay. Yes. This is we call okay. This is minus. Okay. This last term is plus. So even a ratio theorem, rational theorem can do this. Newton method Newton can do this. All let's say the ancient or the classic methods okay can be applied to solve this question. Hence the theory of Mr. Martin really is always for any of the equation. The asset skip payments one will give you the behavior of this polynomial that we are going to work with and will give you the real coefficient and of course solve the problem. Okay, solve he started. You see? Yeah, he started doing okay. Please go. This is trimester. You see? So it's illegal to do this kind of question. Mr. Sultan is here to let you learn how can you use the decimal formula of Mourad Sultan and solve polynomial to the power 10. Even solve polynomial to the power 11. Even solving polynomial to the power 12. 13, 14, 15, 16, 17, whatsoever the power of the polynomial, okay, it's possible. So here you see all the graphs, okay, graphs, all let's say the roots are imaginary. But here in this example, we gave you only what, okay, so he can solve now, okay. Now we go to ChatGPT. ChatGPT, good morning. How are you? You told that you are very intelligent. You told you told that you can solve equation. Okay. Yes, I can solve various types. Good man. I take this. Good man. Good. Take this, my kid. Yes. Ah, yeah, yeah. Solve this and tell me if it is real or imaginary, and don't lie on your income. Go, go. Okay, the equation. Okay, do your best. Too solid. Okay, such degree. Okay, we okay. Numerical method and stop it. Not possible to apply this numerical method. Not, Newton, eruption, the root finding algorithm. No, we don't. We can't do this. Okay, approximation technique. We will stop it. Do it. Do it, please. Do it, please, and give me the answer. Do it. Let's restart it. Okay. Okay, he will try. Okay. So, these are the roots. 1 plus 8 approximately. Okay, take my, take my examples, examples, and check. Okay, okay. So that he hasn't say, sorry, sorry, it's not correct. It's not correct. Okay, go back to Python. Go back to your knowledge. Go back and okay, it's not correct. Okay, again, no, we don't have a no, no, there is no read. There is no read road. Sure. Okay. Our complex with 50 digits. Okay, if you like exact symbols. I will give you, okay, thank you for providing, okay. No, no, it's not true. It's not true. I will give you the roots. Option. I will give you the roots. Okay? Okay, I will give him the roots. Okay, these are the roots. You see, there is no real roots. He wrote me two roots using Python. Something unbelievable. Take this and get the rest. Oh, thank you. Okay, do your best. Okay. Okay, do your best. Do your best. Verification. Subservice agent communion. Satisfy. Memory code. You have hit three limit. So the roots are that. You can guess it. Okay. I'll take this first. These are the roots. Of course, this is equal. Equal. This is equal. Okay. You see, in this example, he gave me two reasons. Really catastrophe. How he found these two reasons. Okay. Take this. These the roots. Okay. Good man. What's happening in the equation? Okay. The English. Okay. Corresponds to the relation to these roots. So these are the roots check. These are exact roots. Just okay. If you want to check, if you want to check, it's better. Okay. And don't give on it. Right. Alas, this is ChatGPT. He used his intelligence and his Python algorithms, but he didn't find the solution. Okay, he gave me two rebates, and this example has no rebates. Thank you for listening, and now we end this game. Start this.